Hey guys, it's Udbhav from Team 19343. This video is a continuation of my FTC programming course in Android Studio. In this video, we will be covering the basic logic of FTC coding. This encompasses the different steps we need to take to elicit actions from different hardwares, such as motors and servos. To begin this video, we need to have Android Studio downloaded with the forked GitHub repository. If you do not have these downloaded, head to the first video of the series, which is linked down below. Now, first of all, let's understand some of the basics of FTC Teleop coding. FTC Teleop programming is done using an existing Java library, which includes multiple first tech challenge specific packages and classes that work with affiliated components such as GoBuilder and RevParts. These include our servers and motors, which we'll be covering later in the series. If you want a more in-depth understanding of classes in Java, check out this video in the description. FTC programming logic follows a basic initialize, name, give, value, the basis for coding the components. So for example, you can see we initialize, we can give a value, and we can set different modes for the same. There's a naming and initialization line, then there's an action line which gives a certain value for the component. This value can mean different things for different commands and components. So for example, when we're coding the motors, the number ranges between 0 and 1, where a higher number means a faster rotation speed. Next, let us move on to the different operation modes in the FTC library. There are two main modes, OpMode and Linear OpMode. Now, while there is another autonomous mode, it is very rare that the teams use it, as there are other libraries for autonomous coding, such as FTC Wire's Roadrunner. Firstly, to create a file, right-click on the first inspire section, go to New, and create a Java class. Let's name this one OpMode. In OpMode, there are 5 methods within the code. Init, init underscore loop, start, loop, and stop. Code underneath the init method happens only once on initialization. Code in the init loop method happens repeatedly during initialization. Code in the start method happens only once after the program itself starts. And code in the loop method happens repeatedly after the program starts. And code in the stop method happens once after stopping the program. Wow, that was a mouthful. But don't worry, because linear op mode is not nearly as complicated as op mode is. Linear op mode only has one proper method, the runoff method. This is where all of your code will go. However, this code can be segregated using submethods, such as while, which acts like a loop, and the wait for start, which waits until the start button is pressed. We personally use linear op mode for our teleop code because we find it the most intuitive and simple to use. Finally, let's discuss the driver hub and its role in executing code. The driver hub is an essential component in connecting the code to the robot and its components. I'll be using the Rev driver hub. Firstly, we must create a configuration for the code. When we create our code, we give each component a name. On our physical robot, these components will be wired to the control or expansion hub to a certain port. The driver hub configuration must have the name of the component corresponding to the port in which the physical component has been plugged. So for example, let's say we name a motor as motor 1, and an axle motor is connected to port 0 in the control hub. We must ensure that in the configuration, underneath port 0, that the name given is motor 1, the same as which is given in the code. This is the only way that the configuration will be able to recognize the motor and have it do certain functions based on the code. Otherwise, it will not be able to perform the action in real life. Now that you have a basic understanding of how FTC Java programming works, you are now ready to start coding your components. A huge shout out to Team 7477 for the existing programming playlist that really aided in the creation of my own. Stay tuned for the next video in which we will learn how to code servos. This is Uddhav from Team 19343 signing off. Peace. Damn, that was cringe.